So quadratic equation will be if the delta b squared minus 5 is greater and equal than 0, we get the real solutions. So do you notice how we graphing this one? How we graphing this one? How we graph this one? When we graph this one, yeah, we have put this. Let me put this a little bit bigger. Graph this one. Actually, you can see when you graph this one, these curves, how we graph this one. Firstly, everyone can use the table methods, find out several spot, but the several spot need to be find out, use the table. First method, use the table methods, right? You can find a pairs of X and Y and find several different spot based on X and Y. At least need about 3 or 4, at least need 5 points. So you can graph this one. But if you use these tables, most of the time, important thing, you need to find when X equals 0, Y equal what? Y equals C, right? So they have the X, this is called when X equals 0, Y equals C, right? Did you see this one quadratic equation here? Right, when you got it here, so you can see that this is called y-intercept. This is y-intercept, right? When you're graphing this one. So at the same time, when you make the y became 0, y became 0. So actually you need to find out x-intercept. X-intercept, just what we say here is use this quadratic formula, right? Plus, minus, negative b plus minus here. So you got x-intercept. X-intercept actually less 2 points, maybe 1 point, maybe 2 points. Depends on this deviation. If they greater than 0, have 2 points. Let me split this out. So actually this x1, x2 can make this become 0, right? If the deviation is equal 0, they only one x-intercept. You guys remember here. So they only one, they just only one. This is exactly vertex. So at least have the 3 points you need to find out. But that's not enough to graphing the line, right? So table methods is the first method we can graphing. Okay, but what's the rest? So if you close look at this graphing, actually there's more character we are missing. What are we missing? Right. So we didn't know the vertex. We didn't know the axis of a symmetry, right? We didn't know this line yet, right? We don't know this line yet. All right, so what we want to do today is try to see what graphing will be changing if you only, how you find these kinds of axis of symmetry, how you find the vertex, and what their A, B, C change would be leaded to graphing change. This is first topic. We talk a little bit during the semester. We talked about this one, but I think we need to go back to review this one. This is so important. Right, let's see what's going on here. So let's give this one examples. Okay. So firstly, what we need to do is we change this one into what? Everyone can do this one right now, right? So we can change this one into complete square. Right, let me disable and you guys running on the whiteboard. Okay, so this one first step is complete square. Anyone can do the complete square? complete square. Complete square. All right, so it's x squared plus 2x, right? Complete square is use this number over 2 and make it a square. Actually, it's 1, right? We add 1 here. A minus 1, right? Make it become 0. We add 1 and minus 1, so still. And copy the rest 3 down, right? This one actually is 0. We add 1 and minus 1. Okay? So this part became complete square. So this one can be changed into, right? Plus 2. All right. Okay. Okay, someone, okay. All right, so this one will be changed into complete square, make it our easy to graphing. Why make it easy to graphing? Firstly, when you set x, it became 0. All right, so when we still go back to say x and y, we're trying to find the x and y. When x became 0, you can see easily to find this part became 1, right? 1 plus 2 here became 3, right? The same thing. If you, of course, if you put this back to the initial, very initial description, you can find out the x equals 0, y equals 3 as well. You can see also here, when x became -1, make this part became 0, -1. So this square became 0, became 2, right? Right? So x became -2. -2. You can go to here became what? Also became 3, right? Yeah, so that's 3 of the point. You can easily to graph this out. Let's see. 0, 3, right? All right, -1. -1 here became 2. 2 here. When you -2, here became 3 again. All right, so this is, if you can connect this one together, you can find out. Okay, let's go back to see this one. What's the axis of a symmetry? X equal -1, right? This is one axis of symmetry. And what's the vertex? What's the vertex? X equal -1 is symmetry. What's the vertex? Here is -1, 2, right? And mouth is open up. All right, so you can got this one quickly. And what's the y-intercept? 0, 3, right? But this one, they didn't have the x-intercept. There's no x-intercept in these kinds of graphing, right? So you guys can easily graph in this one. You can see the vertex here and axis of symmetry. And right now we don't, in this graphing, we don't have x-intercept. And y-intercept is 0, 3, right? So anyone have question to how to graph in this one right now? Wesley, important things, remember this one quadratic formula. Second thing, when you do graphing, try to find the x-intercept, y-intercept, x-intercept, y-intercept, and vertex. And this is called axis of symmetry. And all the mouth open is up, right? Mouth face is up. Okay, so you guys notice this one very well. I know someone's hang up there and had tried to have ask questions. Anyone have question of this part? All right, no questions, no question, good. All right, so we want to go a little bit new here. Let me see. Okay. let me see. All right. So, this part. Okay. So everyone know this graphing is based on y equal x squared plus 2x plus 3. When we know that A is 1, B is 2, C is 3. All right. So C is here, is C equal constant number equal 3. So right now I want you guys to graphing of this one. Can you guys graph this one? What about 5? Just like C was changing. If the front part is the same, what would it be changing? All right, C became 0, all right? We have typical case. If they became bigger or became smaller or became 0, what is change? Can you guys graph in this one? All right, take your notebook, graphing on your notebook. Let me see, what's the difference between these three? So C's keep changing. Right now C is changing. C is changing. What graphing was happening change? We know how to graphing x plus x squared. Just C, just the ax squared plus bx is the same. And then C keep changing. How to graphing it? How to graphing it? Anyone have question to this, to earlier, how to make a complete square? Unmute yourself, answer me whenever you guys can do, all right? Okay. All right, let me give a hint here. So since these two parts, just like here, the front, if just like basically saying if these two part was not changing, only C changing. So when we do the complete square, actually their complete square part was not changing, right? Right. So let me replace this one with the C. This one with C. All right. All right. So this C, what happening to the C? C minus 1, right? Because we add 1 into to prepare complete square. And C became C minus 1, right? Doesn't matter what the C number is. So it means what? So it means the axis of symmetry. This axis of the symmetry, the center line is -1. It's always the same, right? That all this graphing after you complete square, their axis of symmetry is the same, right? Okay, let me graph in here. This is y, this is 0. This is x. Excessive symmetry -1. Excessive symmetry always is this one, right? 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 This always -1 here. Always -1 here. They didn't change. They keep it always the same. What's the so let's graphing initial one first. Right now here, the earlier is 3, right? The 3 is so let me use the red color for the first line. Red color for the first line, all right? So their y-intercept is 0, 3, right? Right now we're just graphing and the vertex is -1, 2. And then when they became -2, here is -2 and 3 as well. So the line you can graphing is like this. That's the first line. What about second line? Let me change the color back to something different. I use the green color. Oh no, green is not a good idea. Back to blue colors. This is the first one. First one here is right here. Second one, we go back to blue one. So so you can see this one is, we can rewrite it into what? X plus 1 square plus 4, right? Plus 4, right? So the line is what? X-intercept is what? 0, 5, 0, 5, 4, 5, X-intercept. What about the vertex? Is -1 and 4. -1, 4 actually right here. And then became -2 is still go back to 5. So when you graph the three lines together, actually became this, right? Do you notice what? Looks like this parabola curves is move the red part 2 units up. You can see this one vertex actually -1, 4, right? Here is -1, 2. So just move up 2 units, 1 unit, 2 units. Everything move up 2 units, right? All right. Let me, so here is the third one. Third one became what? So 3, here 3 became 5. Look all kinds of unit, up 2 unit, up 2 unit. Right? Hey, someone do in the chat, stop chatting there, all right? Don't chat, go there, go back to draw questions. All right, let's see. So let's see this one. So here 3 became -3. -3. So this complete square will be changed into x plus 1 minus 4, right? Minus 4. The accessible symmetry still x equal -1. -1. So what's the vertex? Vertex is -1, -4, right? -1, -4. 1, 2, 3, 4. Actually, negative right here. So what about the y-intercept? 0, -3. When I -2, x equal -2, here you can here. So you can graph it like this. So you can see the number from red one is C is the +3, change into -3. So it means looks like the unit y move down 6 unit. Here is +3 and then move down 6 unit. Right? This is 0, -3. So look like these parabola curves, all unit move down to 6 unit. All right, let's see last one here. See last one here. Let me ping it. So when this make a complete square, is what? X plus 1 square minus 1, right? So what's the vertex? It's -1, -1. -1 is right here. And C is 0, means the y-intercept is 0, right? So when x equal -1, -2, y also equals 0. So when the line became here, you can graph this kinds of line like here, right? Here is number 4. Here is the number 2. Here is the The purple one here is the number 3. Did you notice what relationship of these kinds of curves? Just move up and down, right? So C changing, if you keep changing the C, it means these parabola curves just need to move up and down, right? C from 3 to 5, move up a unit, 2 units. From 3 to -3, move down 6 units. When you became 0, actually down 3 units, right? So C changing didn't change too much of the parabola curves. They didn't change the shape, it became more thin or more fat, right? They still keep the initial space. The only change is just move position up or move the position down, right? Is it correct? Hello, everyone. I'm the only one talking so much, right? I need a question. Anyone have question here? Question someone first. Angela, do you understand what I'm talking now? Okay, what about Bradley? Bradley, are you still there? Can you answer my question? Is it good?
Yeah.
You do. Mason, you learned this before, right? Already?
Yes.
So we talked a little bit earlier, and we didn't talk so details. But this time we talk very detailed. So C changing, just make these parabola curves move up or down. Just try to make sure what the C direction change, right? They didn't make the curves become more thin, didn't make the curves more fat. It didn't change the shape, just change the position up and down. We just keep repeating this one. All right. So since nobody have questions, we move to differences. All right. Okay. All right, everybody understand this one, right? Right now. So let's still go back here. So we say y equal x plus 2x plus 3, all right? Right now we say C is this one, keep changing, make the parabola curves become up and down. All right, right now we change it here. We're not changing this one. Right now we're changing this one, B. Okay, change B. Change B. What B? So all right. So you guys can do something here. If the x squared became here, became 0x, all right, plus 3. When x squared became, do you guys need a break?
Yes, please.
Wait a minute. Let me talk.
Yeah.
Let's talk and we'll be changing. All right, okay, negative 4x. All right. If you this one became positive, even bigger than here, we say 6x plus 3. All right. So the only change is here. Negative 2 became 0, became negative, became positive. What parabola curves were changing? So let me initiate. You guys can working on this one. I'll take a break. 5 minutes, come back, we'll talk about this one. All right, 5 minutes break, come back 5:11. All right. So I just keep drawing this one so we can continue talking quickly. All right, just see you soon. Take a break, 5 minutes, come back 5:11. I just keep drawing this first one first. So this is excess of symmetry. Here is negative 2. So initially, oh no. All right, you guys can continue working on this one. Mm-hmm. Okay, 1 more minute. All right. How can I disable you guys chatting there? Someone do. Dun, 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 dun.